Good evening, all the attendees from India, and good morning, all the panelists, or most of the panelists from US, to this Indian Physics Association American Physical Society webinar for young researchers who are for orientation of young researchers who are publishing or going to publish with APS. To begin with, let me say a few words about Indian Physics Association. It was founded in 1970 and has been active platform for physics community with emphasis on engaging with young researchers. And we have specially arranged this webinar particularly for young researchers who are PhD students and postdoctoral fellows, and just to help them out and get good perspective about publication, particularly with American Physical, journals of American Physical Society. And on behalf of the IPA president, I extend warm greetings and warm welcome to all the attendees as well as all the panelists. Unfortunately, the president could not make it here today. And we also have General Secretary of IPA with us today, Professor Vandana Nanal. But to begin with, I would like to invite Professor Michael Tennyson, who is Editor-in-Chief of American Physical Society, and also Professor in Michigan State University. And I welcome him to give us the initial welcome remarks from APS.
Thank you very much. Let me quickly share my screen. I prepared a few slides. Okay, I think we're ready to go.
Yes.
So welcome everybody, and thank you very much for spending your evening with us, some of the editors of the Physical Review journals. I hope that this will be an interesting webinar for you, and I hope that you will ask lots of questions and we'll have the opportunity to get those questions answered. So let me just give a brief introduction about the Physical Review journals. They have a very, very long history, and they have been published by the American Physical Society since 1913. At the time, it was just the Physical Review. And as you can see in the timeline on the right, it actually had been the first issue of Physical Review started even earlier in 1893, 20 years earlier, when they were independently run, and then later on taking over by and managed by the APS. Then in 1930, we started Reviews of Modern Physics, which is one of the most highly regarded broad review journals in physics. And it took another 30 years before the next important milestone happened, and that is the need for a short, fast publication journal of very important results, and that then became Physical Review Letters, started in 1958. Mostly due to practical reasons that physics was growing so rapidly and so much that the Physical Review volumes became bigger and bigger. They couldn't be bound in books anymore. That's when we decided in 1970 to split up the Physical Review into 4 subsections and very appropriately named and innovative Physical Review A, B, C, and D. 1993, they were split. A was split in A and E, and then later on we started various other innovative approaches serving really the broader physics community. And the first open access journal was launched in 1998, which was the Physrev Accelerators and Beams. followed by physics education research. And then a few years later, we realized that it's important to really, again, because the research output grew so much, it was important to highlight even more certain very important results and help readers to focus on the most important things. And that resulted in Physics, and which we now call Physics Magazine. I'm going to say a few more words about that. And as you can see then over the years, PhysRevX started, another fully open access journal highlighting high profile results, and then branching out in response to the demand and the changing communities. And the most recent one is the start of a series that we call PRX. You might want to call them PRX babies. And the first one is PRX Quantum that started in 2020. So that means that currently we're publishing 15 journals plus Physics Magazine. That results in a total of about 20,000 articles every year. And you can imagine that is a major enterprise to do. And for handling all the papers, we employ about 160 editors from 37 different countries. Some of them are located here in Ridge in the editorial headquarters, and others are scattered all over the world. This is a nice overview of an article that was published a couple of years ago that analyzed the cross-citation of articles among all the journals. And what they found out that the physical review really is at the center of physics because it has the highest rank of centrality. They analyze and define the relationship between citations between papers. If you're interested, this is a very interesting analysis and paper, and we're very proud of it. It was completely independently done from us. Here is geographic distribution, and you see that although the American Physical Society publishes the journal, the Physical Review are much, much bigger. They're really fully international. And the contribution from the US actually is only a third. Most of the papers come from outside of the US. And you see that India currently accounts for, well, 1%, only 1%. And this is one reason we do this event, because we want to encourage and enable researchers from many, many more countries to contribute to our journals. Just going to highlight a couple of things, and that is the launch of the most recent journal, PRX Quantum. It's a fully open access, highly selective journal covering everything in terms of quantum information. And you see here a couple of papers. And there we tried something different that we hadn't really done before, and that is the journal publishes perspectives and tutorials. And you see a couple of examples, recent examples here. And although it is open access, so we charge article processing charges, but they are currently waived until the end of the year. This is an announcement that you've probably seen. We are about to launch the next PRX subjournal, that is PRX Energy. Again, it's highly selective and open access. And we will start receiving submissions later this year, and the APCs will be waived until the end of 2023, until 2023, the end of 2022. So if you're interested in finding out more about PRX Energy, and actually if you're interested in finding out anything more about any of the journals, you can sign up for alerts. Here's the link. If you just go to journalsaps.org, you can make your way to the various journals where you can sign up for a table of contents or other information about the journals. And I apologize, I squeezed in another slide before. I'm going to talk a little bit more about that. One other recent change that we did is, again, in response to the community and the authors and the readers, we felt it was important for each of the subfields in physics to highlight their most important content more. So at the beginning of the year, each of what we call the archival journal introduced a letter section that they are now publishing letters in these journals. So I talked about the alerts, and here is the link, and I mentioned PRX Quantum, where you can sign up to get information. I also encourage you to sign up for Physics Magazine. I mentioned that they are really highlighting not necessarily the most important research, but the most interesting research. And if you sign up, you get a weekly email with the very interesting articles highlighting certain papers, and also having other interesting stories about general physics. And if you want to stay up to speed in terms of what's happening in physics, I think in the latest research, this is a very useful tool where you can get very good information. So one thing that editors struggle, or that is very important to the whole publication process, that is the peer review. And you're going to hear a lot more from our panelists and the presentations that you hear today. And the peer review is done by researchers in the field, external referees. And we are constantly looking for highly qualified referees. And although this is geared towards the young graduate students, postdocs who are probably not ready to become referees, but it's never too early to think about it and understand how the process works. If you are a senior graduate student or a postdoc and feel that you're sufficiently knowledgeable in a certain field, talk to your advisor, to the senior professors, if they are willing to involve you in the referee reports, because this is something that we're encouraging for senior researchers to write joint reports where they involve young scientists, where they basically teach them and show them how to write a referee report. And we encourage those senior researchers then to enter the name of their young colleagues so that they're in our database. And when we see that's a good report, then we probably contact the younger researchers then to write their own individual independent reviews. Another way that you can get involved and being available for referees, you can nominate researchers, and that includes self-nomination. There's a link here, become a referee. If you think you're interested and have a certain subfield that you're thinking that you can referee papers, we ask you for your field of expertise, and then we can enter you in the database. And if there's an appropriate manuscript, that we can use you. With that, here's the list of seminars that you're going to hear today, followed by the panel discussion, and I hope that it will be very useful and that you ask lots of questions. And with this, I stop sharing my screen. Thank you.
Thank you, Michael, for your welcome remarks. And now I welcome Amy Flatten to give us, who is the Director of International Affairs of American Physical Society. And I welcome her to give initial remarks from her side.
Hello, everyone. As he said, I'm the Director of International Affairs for the American Physical Society. And I want to give just a few moments on the ways that APS can serve you beyond even the journals. And the reason I find it so important to talk to young people outside of the United States is that we have been hearing that many young people who aren't in the United States assume that APS is only for people that live in the United States of America, and that is not true. Along with our journals being very international, our members are very international. With a membership of about 50,000, almost 25% of our members live outside of the United States, and we engage with physicists across the globe. We provide opportunities for physicists in any country. And I want to highlight a couple that might be of particular interest to you. We give a free one-year student membership to anyone, anywhere. And I want you to have this web link, and we'll of course put this in the chat box as well. But on our website, we allow you to click on India, click on a map, and see all the programs that are available to people that are specific for your country or your region. And as Michael has already showed, our journals are, of course, very international, but we bring physicists together from all parts of the world. Our March meeting brings people from, as we said, in 2019, 63 countries, and 2021, 71 countries. And we advocate for policies that enable you to come to the United States to work and study. But we really want to encourage you, whether you're a member or not, please participate in the APS community and engage with our society. We would welcome the opportunity to serve you. Thank you so much, and we look forward to the webinar.
Thank you, Amy. Thank you for those introductory remarks from the society. And now let us start with our first main event, which is the first seminar. And this will be given by Professor Matteo Rini, who is editor of Physics magazine and also associate professor at adjunct professor of science writing and communication at New York University. So Professor Rini, please.
Thank you. Thank you very much for the introduction. Can you hear me well?
Yes, yes.
Yes, thank you. Thank you, everybody. I'm so glad that you are here. I'm so glad that I get a chance to talk about something that I think we don't talk about enough in the scientific community, which is how to communicate science in a way that it is a little more accessible. I actually have to say that this kind of seminar started to be organized about a year ago, a year and a half ago, just before the pandemic hit the world. And I was basically on a plane trying to go to India, and I was touring. I see some of the people that I should have visited back then. And that's when I realized that COVID was actually going to change things. And so these things didn't happen. We had to postpone it, but I'm glad that we can do it now, at least in a virtual form. We can all have the chance to interact. But I really hope that one day we'll be able to travel again, come see your institutions, come meet everyone at your institutions, and build stronger links. So we're really happy to talk about this issues. We do quite often. We've done seminars for the Brazilian Physical Society, for the Chinese Physical Society. So we're developing sort of a little curriculum that can help scientists with specific parts of the publication process and of the review process. So the first part, my talk will be focused on writing better scientific papers. And then Shami will instead talk about publishing, so the whole system of publishing, sharing some insights from the perspective of an editor with a long-standing experience. So I'll start with my part, and as you see, my talk is focused on writing, and I'd like to start with a first slide that I'm always giving before starting my talks. And this slide is this idea that as a scientist, you are a professional writer. Maybe we can broaden it up. As a scientist, you are a professional communicator. And this is a responsibility that sometimes scientists don't feel they own, don't feel that they have to do this. And if, I know plenty of scientists and they're ready to do many, many things for their career. They're ready to spend months learning a new programming languages. They're learning to align a new laser that they just bought, or operate some machineries. But it's very rarely they spend some time trying to work on their writing and communication skills. And I think this is a mistake, because these skills are actually what allows your science to be seen as it should be seen, what allows your science to speak to other scientists that could be inspired by your work, to speak to your competitors. In other words, it allows your science to matter. So I really very strongly believe that you should take this responsibility into your own hands. You are a professional writer, so you have to behave accordingly. And I'm not, making the case for complicated workshops or training. I think what matters most is that you focus your attention a bit when you are writing, when you're doing your activities, when you're preparing a conference, and just maybe using things like some of the elements that I'll talk about in this workshop. Try to every time to improve your communication skills. If you do that consistently, very soon, gradually, you'll become a much better speaker and a much better writer. There are many, many reasons to write well, and there are obvious one. Everybody, when I give these talks, think about the first one, getting published. If I write nice paper, I will have more chances to publish more papers. This is to some extent true, although I have to be honest, I don't think that this is the one that's going to be affected the most, because after all, when you're sending a paper for review, the person who's going to see the paper are referees, and they are expert people in your field. They already know what you're working on. You can use the jargon that you need because they can use that jargon. So even if the paper is not particularly well written, that will have a way to understand whether it deserves to be published or not. I think what really matters is getting cited, and citations are, of course, the most important measure of a scientist's success. Take the H factor or other ways of counting your impact. You want your paper not just to be published, but to get cited, and to get cited frequently. And I can tell you the most cited papers are almost always papers that are written well. People have learned something from them. People have been able to access this paper and to get the message that they were delivering. A very important aspect requires good writing is grant proposals. When you send grant proposals, the funding, the program managers who are getting your proposal and analyzing them have a very broad portfolio. So you have to write your proposals in a way that's very, very broadly accessible. You can imagine that it's just your competitor or your supervisor analyzing this proposal. And finally, I think it's something very important, the communication among disciplines. I see that in many fields of physics, I'm really convinced that the breakthrough to come will come from the marriage of different disciplines that come together and bring out something new. And I've seen many examples, theory for condensed matter being applied to the theory for the early universe. I've seen tools of string theory being borrowed to describe condensed matter system, to even design optics. And some of the very, very complex questions from dark matter to dark energy will probably require for their solution the synchronization, the collaboration of many research fields. And so we have to allow this interdisciplinary communication. And this is only possible if your papers are written in a way that somebody from another field can access them, can get the gist of what you've done, can call you up and say, hey, I want to learn about this because it may affect the way I'm doing things. And finally, if you're a very young student and you may not even know whether you want to go on and stay in academia, I think that if you communicate well, you learn some good communication skills during your PhD, they will be very, very useful in any career path. When New York University decided to do the classes I'm giving at NYU, there were many faculty who weren't sure about that course. They were quite skeptical, but then somebody was giving a seminar, somebody from Google, and they said that this was one of the most transferable skills that they wanted the students to have. So definitely Google was supporting this course because they thought that it would be very useful for future hires among the PhD students at NYU. So there are many, many reasons to communicate well. And now let me just give you a little bit of my background very, very, very quickly, just to give you an idea where I come from and why I feel entitled to say the things I want to say through this talk. I used to be a scientist for about 10 years, and basically I was doing this in a sort of 21st version of this. I was doing stroboscopic photography. The first one you saw was done to try to understand how a horse is galloping and try to see how its legs moves. It's the same principle, but I did it with lasers. The idea is that with a camera, like the one used to capture the images of the horse, you have to open and close the shutter. So there is a mechanical time that limits the speed, but with lasers, you can just shine pulses of light. And basically you can make snapshots that are just as short as you can. You can basically see any movement of atoms. And today, probably we're getting to the point where we can see electrons. So this was this is a so-called pump probe experiment. We had some molecules in the sample, and we were deriving some information about how the molecules moved. And this was useful to determine how long certain chemical reactions took place. And I did a lot of work. This is some of the works I published. I was quite lucky in terms of publications. Certainly my papers were written well. I think the most important thing I've done scientifically in my life is this one on water that was highlighted in Science. Basically, we measure a very important chemical reaction by which an acid molecule transfers a proton to a base molecule in water. It's sort of the basis of many biological, industrial chemical reactions. We could measure it. It was 100 femtoseconds. It was 1 order of magnitude faster than any theorists believed. So it was a pretty big deal. And yeah, it's a paper that's been cited 1,000 times. So this is to say, these were the kind of topics that I was trying to tackle with laser spectroscopy. But I didn't stay there. Everybody was expecting me to become a professor and go on with this femtosecond experiments. How it turned out to be was that I took a break and I went to work in politics for a bit. And I went to work as a scientist with the European Commission, where I was there in the middle of lawyers, politicians, policymakers, trying to give some scientific input to their decisions. I was working on different fields, in particular energy and climate change. And it was a really interesting experience. And at the beginning, I thought, you know, politicians or sort of stupid people that will not get, we scientists, we have the truth, we know how to analyze things. And I felt that the problems were on their side. But after working 3 years in that environment, I realized that there are so many problems from the side of scientists in terms of communication. And I remember this key meeting where a famous scientist from Germany went to the European Parliament to try to make the case for more funding for nuclear research. And he had 5 minutes, and within 5 minutes, he was able to say 4 times quadrupolar moment. And obviously that didn't go very well. The politicians didn't have the chance to understand what he was doing. But those experiences made me reflect about the shortcoming of scientific communication on the side of the scientists. So can we improve that? And I decided ever since to work on communicating science. I've done that a bit within the commission, but then I joined the American Physical Society, where I guess my main focus is to communicate physics to a broad community. This is a snapshot of Physics magazine, which you can find here at this address, physics.aps.org. It's freely accessible, of course. And here, basically, we highlight the best physics that's been published, mostly in our journals, but not only. And we have different types of articles. We include highlights of our papers. We have interviews. We have articles focused on arts and culture. I would say that the most important thing that we do are these viewpoints. Viewpoints are articles that are written by experts. So when we have a big deal, say this was LIGO's discovery of gravitational wave, we ask an expert to write a commentary. We want this commentary to be very widely accessible. And so I work, or one of my editors work with scientist, in this case, Emanuele Berti, to produce a commentary that's accessible to ideally every physicist. So this is an important part of what we do. This is another example. It's one of the last papers by Stephen Hawking, who was commenting on his information paradox. So this viewpoint, if we were, the papers covered by this viewpoint, if we were to measure their impact, it's perhaps on par of or even higher than the physics paper published in Science of Nature. So we're really talking about the highest impact paper in the world of physics that you can think of. So this is really the important stuff. But we have other articles, other forms of communicating physics. We're exploring with some more innovative ideas. You probably have heard about the G-2 experiment last year. And we explored the possibility of communicating that finding through a cartoon. And we linked with a great artist, PhD, is known as PhD Comics, and he did this incredibly simple and accessible visualization of the G-2 result. It's a result that suggests that there may be other particles that we don't know of. So it's pretty intriguing. It was the physics result of the year, and he was able to translate it into a way that was particularly simple. So now I'll move on with this sort of intro on Physics Magazine. I will move on to two aspects of the things that I do every day that are needed for me to do my job. And I need to do two things. First, find the best science. I find articles, and there are many channels, I receive many suggestions. And the second is communicate it. And so let me talk about a few of these aspects. The first, finding the best science. I read hundreds and hundreds of papers every week. And each time I read a paper, I have to ask me 4 questions. And I guess this helps me define these 4 questions and something that a good paper should answer rather well. The first question is a pretty general one. It's a motivational question. Why this research? What is the big goal that we're trying to achieve? You're trying to discover dark matter, the nature of dark matter particles. You're trying to develop solar cells that are efficient and durable. So the holy grail, not the one that you are achieving through this work, but maybe the one that you hope that your field will achieve. Then the open questions. I want to get a sense of the specific questions that your paper is going to address. So not the big question. You're not going to develop an efficient solar cell here in this paper, but what are the specific research needs that you may partly at least resolve through your work? For instance, your solar cells may be slightly more rugged, and so they can survive for longer in the environment. Finally, the key result, what is really new? This is a very important aspect. In some journals, it's some articles, you read them, and it's really hard to understand the difference between the new thing and what's been previously done in the literature. So I think that key step is the most important, arguably the most important thing of what has to be properly communicated in the paper. And finally, the impact. What are the implications of the result? I found something, I measured something, so what? What happens now? And I can tell you that there are many papers that completely forget to talk about this. So they say we measure A, B, and C, and they know what it means because that's their field. To them, it's intuitive, but the reader will not feel the same way. So the researchers simply forget to talk about the implications. And I think this is a very, very important part of a paper. The other aspect of my work is editing scientists. So when they produce those viewpoints that you saw, I have to work with them. I have to edit their writing. So I've worked with hundreds of scientists from all levels. I've edited a few postdocs, many early and mid-career scientists, all the way up to Nobel Prize winners. This is an experience that gives me some light into how they think, how they perceive scientific writing. Most of the times it goes very well, but sometimes I encounter some resistance, and I'm sharing this with you. These are some of the emails that I received after this scientist have seen my changes, my edits to their draft. And I think they are exemplifying some of the challenges that are intrinsic in science writing. And so I think they're worth looking at to recognize these challenges. The first is saying, you're simplifying too much. They'll think I'm stupid. The second says, if a scientist does not know what the Lyapunov coefficient is, he and you should just go back to school. The other says, you have massacred my text once again. There is no way to explain this without Hamiltonian equation. So yeah, this is our uncommon, I have to say. Not everybody reacts like this, but I think they're pretty telling of what's behind their thoughts and of the challenges that every scientist perceives when they're trying to communicate. The first, thinking that simplifying means being stupid. I think this challenges reflect the fact that we, in our environment, everything conjures so that we always talk to our supervisors, to our competitors, to our colleagues. So we're talking to someone who already knows, we're talking to somebody who has the jargon, we're talking to impress our supervisors, to be evaluated. So we spend a lot of time communicating the how. We don't have to explain to our supervisor why we were doing something, or so what, the so what of what we found, because they already know. But we are spending time communicating how many hours we were in the experiment, how we solved that little problem, and so on and so forth. So I think this environment is not leading to identify the real audience, who is really going to read your paper and listen to your talks. The second challenge is what I call the curse of knowledge. So this person said, if a scientist does not know what a Lyapunov exponent is, he and you should just go back to school. That person could not, as this curse of knowledge, they could not remember how it was before they spent all those years studying all that physics, and they forgot how it was. They forgot they didn't know certain words. So sometimes we have this curse of knowledge. I do have it myself. If I write about lasers, I am a much worse writer because I think that everybody knows the jargon of laser physics, but this isn't the case. So the curse of knowledge is something that we should try to be aware of and fight. And I think the most important point is the last one. When these people are communicating, they are not relating to the audience. So when somebody says you're simplifying too much, I think I'm stupid, is because he's thinking that the audience is basically his supervisor, his competitors. That's about it. So he cannot relate to the broad audience of everybody who is actually going to be there and listening to his words or reading his words. So to overcome this challenge, a few things, and then I'll move on to some more practical ideas. Write with the reader in mind. So try to develop an empathy for your reader. So try to imagine who is going to be out there sitting with your papers in their hands. It's going to be a young PhD student, it's going to be a postdoc from another country. Try to relate to them and try to have a better, a broader perspective on who they are. The other point is practice. A lot of people think you're either born a writer or you aren't a writer, but that's absolutely not true. Practice can improve a lot. You can learn clear, effective writing communication skills by practicing, by simply focusing on them and reflecting on them while you're doing them. So you don't have to do something special to take classes. Just focus on what you're doing when you're doing them and try to improve. A very important suggestion to me is to read a lot. read a lot of papers from other fields. If you find a paper that speaks to you, if you find a paper that you think is clear, stop for a second, try to think, why is this paper good? Why does it get its message across? And so try to understand what is the style that allowed them to do that. A little word of encouragement for some of you whose native language may not be English. I find from my experience there is absolutely zero correlation between English proficiency and writing skills. When I started this job, I was expecting people in Cambridge or Oxford to send me perfect draft, and it would be very easy to edit them. On the other hand, when I received, a draft from writers from my own country, I was nervous. I thought I would have to work much more. Very quickly, I realized that this wasn't the case. So writing well has nothing to do with not making grammar mistakes. Actually, my favorite writer that I've ever worked with, he writes a very poor English from a grammar point of view. He doesn't know what an article is, but his writing is so logically organized, is so well put together, is even poetic. You just correct the sentences and you get a perfect article from him. So writing is not about grammar and about not making mistakes. There are ways you can even hire for very cheap editorial services that can correct this. But writing is about logical flow. It's about telling the right things. It's about answering the questions that matter to the reader. So I'll get a little more concrete in the following, and I'll talk about the stages of writing. This is how I typically work with my writers, to try to give a little bit of a structure to the process of writing, which sometimes, it's a bit hard to define. It's a very creative thing. You sit down, you start throwing out ideas. And so I have tried to build a little sequence that for most cases work. And the first step of writing is actually finding your stories. So what do I mean by that? And I'm really convinced that a paper or a scientific tool is actually telling a story. Some people are a little scared when I say this because we're not talking about fiction and so on and so forth. But by story, I mean the central story that you want to tell, the one message that your paper is delivering. It has to be a simple one. It has to be one that you can summarize in 1 or 2 sentences. It has to be that message that captures the main finding that you are presenting through the work. In this, you should do at the brainstorming stage before even starting to put a word on paper. You should start reflecting. You should do a lot of brainstorming, and the longer the time you spend there, the easier the writing will be done. So what is that story that you want to tell? And I'll give you some example later. So, but once you have that in mind, having that story in mind is also very helpful because it helps you presenting the results. So if that is the story, what are the elements that you need to present this story? And so that will help select all the other parts, what experiments you need to show to make the case for your story. And a story is something that should be summarizable in a couple of sentences. And these are some summary of stories, and let's take one. A good memory for light. A solid-state optical memory stores a light pulse and even a full image for more than 1 minute, the longest light storage time reported in any system today. So it's a very concise, compelling little summary that gives the essential result without adding any other element. It's fully understandable. A great use of a sentence like this is in the cover letter for an editor saying, hey, we're submitting this paper with this title, here's what you do, and then you have your story summary. And I want to contrast in particular storytelling with data presenting, and I'm using 2 extreme cases. This is a paper in Nature by Rosalind Franklin about DNA. This is the X-ray diffraction pattern of DNA. So that's data. That's presenting data. On the other hand, this is the paper by Watson and Crick, where from the same data, they extracted the helical structure of DNA, which of course has so many biological implications. So here, obviously, these are data and this is story. And this is an exaggerated example. These two papers were designed, I think, together so that one would present the data, the other the analysis of the data. So, but I would say, think about your own work, and there are many cases where you are not telling the stories. I see many papers where the gist of the paper is presenting some data without thinking so much about the story that's behind this data. So I think this is the context that I want to build. Storytelling is not presenting data, and too many papers just limit themselves to presenting data. Also, I firmly believe that every paper should tell not more than one story. Sometimes I see these cover letters where authors are trying to push their papers to publication because it did A, and it would B is solve the fundamental problem, and C, it's the fastest decay time ever observed, and 3, it has some good aspects for producing large-scale devices, and so on and so forth. When you're giving 5, 6, 7 motivations to the editor, I think that the additive property doesn't work here. All you need to do is to give the editor 1, maybe in some cases 2 reasons for publishing your paper. If none of these reasons is sufficient for them to want to publish this paper, they will not publish, even if you have 20 reasons for doing that. So focus on the main story and build your paper about that main story that you want the editor to get. Once you have your story, that will help you define a story structure. And the course, there are many options here. In the courses that I give, we can explore different structures, different type of magazines. Science is something different than others. But I would say that the classical structure for a scientific paper is something like this. It's connected with the 4 questions that I was talking about. It starts with the context, the broad why. What is the big picture? We want to understand what dark matter is. Research needs a more specific why. Within that context, why? What are the specific questions that you're trying to answer? Say you got a gamma ray signal from the center of the galaxy, and you think it may come from the annihilation of axions. You do some modeling that rules that out. So you're not solving the big dark matter problem, but you're solving a more specific one. The third part is what we did and found, the how, so the core of your paper, the analysis, the theory, the modeling that you want to present. And the fourth, the implication, the so what. So you found something, you calculated something, what happens now? This is, again, a section that is very, very often completely forgotten. And people just stop when they presented the result and do not connect with the reader by telling them why these results matter. So I think this is a common shortcoming of scientific papers. When you are thinking about the structure of your paper, try to analyze, try to identify the big sections of your work, try to develop an outline. And as you are writing, or before you're writing, you try to have one. And as you are writing, try to have multiple iterations where you're modifying the structure outline, which can be very detailed. But at the end, when a paper is written, this outline, you have to look at it, and it has to be extremely logical. And very important part in the structural analysis of your paper are the paragraphs. The paragraphs are the unit of composition. So a paragraph ideally should, it's not just a certain length of text after which you have to start another one. A paragraph should be communicated a coherent unit of thought. So you could summarize that paragraph in one sentence, and a well-written paragraph actually does that. And I could show you some example, but so there are various options for doing this, what I call point first paragraph and point last paragraphs. So in this paragraph, there is a focal sentence that sort of gives the gist of the paragraph, a little summary. It could be almost the title of the paragraph. And I can show you one example. For this is from the LIGO paper, the discovery of 2 gravitational waves. It starts by saying the basic features of that number is the event they detected, the signal from that event, pointed to be produced by the coalescence of 2 black holes. So that sentence basically tells you what's happening in the entire paragraph. Then they go on and describe to say all the analysis, all the data that made them think that was the merger of two black holes. But they give you the focal sentence first, and then they give you the analysis that backs up that conclusion. So if you look at a paper that's written with these focal sentences, you can look at from above, and you can jump from focal sentence to focal sentence. You get you can do what I call nonlinear reading. You can really run from one part of the manuscript to the next. You can find the things that you want. You can see the very clear logical structure of the manuscript, and it's a very powerful way of writing papers. So think of paragraphs as logical units, and try to use focal sentences that summarize the paragraphs and allow the sort of non-linear reading possibility. And the last part of my tips for writing is focused on finding the best language for the story. So you found your story, you built a structure that tells the story. How can I effectively write that story? And I'm going to present a few thoughts and a few principles for doing this. Two important ones: economy and lightness. Again, do not think that you're speaking to your supervisor. Do not think that you're speaking to somebody who is judging you. You don't have to speak in a stuffy manner. You can speak as simply as it gets, provided that you're not losing accuracy. Economy is a very important value. The secret of good writing is to strip every sentence to its cleanest component. When you are an editor, most of your work is cutting clutter, is eliminating things that are not necessary. We have a very foundational principle in science, Occam's razor. If you have two theories and one is more complex than the other, but explains the data, but both explain the data, you have to go for the simpler one. And I'll say, by the same token, in your writing, the simpler wording that conveys your message is the wording that you should go for. Don't try to make it more complicated than it is. So there are many things that you can do. I'll give you some resources later, but here's some things, some attempts to choose for quickness and lightness as opposed to sophisticated and complicated. Lately, I've been handling a lot of papers about bird migration. There are some ideas that birds might be able to migrate on Earth's magnetic field using quantum mechanical effects. And most of these papers, they cannot call birds birds. They call them the avian species. And in the beginning, I was a bit confused. I thought they were not actually the same thing. Maybe some birds are not avian species, or some avian species are not birds. But really, the only reason for using that, for using three words instead of one, for using something more complex as opposed to something simple, was that they wanted to sound scientific. They wanted to sound academic. So, and I think this is just a metaphor of many, many times where we choose the avian species over birds. But I would argue, if we can use birds, we should always say birds and not go for an expression whose only purpose is to make us look academic. And there are many other things that you can do. Recognizing clutter. This is a sentence that typically doesn't add much. It's typically found in the conclusion of a paper. This work sheds new light on the physics of whatever we studied in this paper. What is new light? So basically, this sentence is telling you this word tells something new on the physics of this field that you know that we were writing about in this paper. Sentences like this do not add anything to the content. So you should just delete them, or if you want to be more precise, you can explain what that new light is if you haven't already. Many other parts of the, many other words are simply not necessary. Adverbs are very often useless. And a Nature editor told me once, when she received the manuscript, she would replace automatically very with bloody. and then go through the manuscript and delete, obviously, the blood in every instance it occurred. And she said the end result was absolutely that I had not lost anything. So something is large or very large, it doesn't really matter. Something got conclusively demonstrated, it means it got demonstrated. If it was not conclusively demonstrated, it was not demonstrated. So most of the times adverbs are useless. Another note on active versus passive voicing. A lot of people don't like to put themselves in the front page, and they prefer passive voicing. This has been measured. Passive is slower, is longer, it leaves an open question, who did it? I would say as a general trend, try to favor active voicing. I don't have time to go through this, but a lot of us, sometimes it's an attempt to write better. When I started, I thought I would have to compose very complicated, convoluted sentences. And if you read this sentence, you can barely breathe. And it's really hard to extract the logical connection between the different parts of the sentences. You read it and just doesn't work. And if you break it up into two sentences, then you have three sentences. Two are explanatory, and the third introduces a logical connection. And you read this and immediately you get the concepts. It's not that this one is written poorly. In principle, you have all the elements, but they're just put together in such a complicated way that it is really hard to process. There are many examples, and I'll give you a reference where you can find many suggestions on how to substitute clunky phrases with simpler ones. At the end of my talk, I'll give you an example of that. And just a general comment on the fact that, do we really need to sound that academic? Do we really need to depersonalize science, to make it sound, to strip it of humor, of our personal view? And I would really argue that we can sort of fight that tendency. And first of all, using I and we pronouns, and something that a lot of people resist to using. This is a paper by Einstein, and there he says, I have shown. Back then it was entirely normal. It was like one author paper, and he said, I have shown. It was absolutely legitimate. I think we are losing this a bit. A lot of people go to great lengths to avoid using we in their papers. My personal opinion is that we should do it. We are the actors doing the science. Why should we hide it? And some example of these are all taken from Review of Modern Physics. So it is the journal in physics with the highest impact factor. Some examples where people put some humor, some personality in their writing. This was the initial title on the breakdown of the Born-Oppenheimer approximation for conical intersection of potential energy surfaces of the same symmetry. The key message is that this conical intersections are very hard to treat. And after title, the title that was chosen after the edits was diabolical conical intersection. It's a much more engaging for the non-expert. It doesn't tell much more to the expert who already know that conical intersections are those where the Born-Oppenheimer approximation breaks down. So it works better for anybody. Some sort of humor or funny sentences that have found place in very prestigious articles by very prestigious scientists. I've observed that the Hamiltonian philosophy is like avocado. You either like it or you don't. It works very well. The one thing you wanted to say was that I don't have any theoretical preference for doing it one way or the other. The two are equivalent. So it's very personal. This other quote from Review of Modern Physics says the fluxes from this star are still changing on timescales short compared to your journal publication timescales. So there is space for a little bit of fun, for a little bit of personality. And I think if it's done well, we don't have to feel that we have to depersonalize science. And I'm concluding now. Just wanted to talk about a few more principle that I think should inspire the writing of a paper. And the first is visibility. We think in power of images, and images are very important. This is the DNA paper. As you see, that helical structure gives it all. Images are a very important part of your work. And a good tip is to build a paper around the figures that you're going to show. And then focus on the figures and on the caption, and try to tell the story that you're telling through the paper using the figures and their caption. Do they tell a coherent and simple story? And if not, try to make them more efficient and more accessible. And I can tell you that many people, funding agents, journalists, other scientists, this is a very common way of reading a paper, going through the figures first. They read the abstract and then they march through the figures and they try to get a sense of the physics that's being explained through the figures. The other aspect, sorry, this is not visibility, but the other aspect that I want to talk about was multiplicity. So forget about this. This one should be multiplicity. So I told you we're not writing for our supervisors and competitor, but we can write for them too. So multiplicity is this idea that a paper can be accessed at multiple different levels. There can be section of the paper that can be accessible to everyone, and other sections that can be accessible to the real expert. So design your paper so that there can be different entry points, there can be different sections. In this case, every researcher, for instance, should be able to understand the abstract, maybe the introduction. Then the next paragraph could be accessible by researchers in related field. And then there's a core of the paper that is really only the expert can digest. So a good metaphor of this is what I call a hourglass structure. Your paper should have a hourglass structure where it's very broad at the beginning, very accessible, and then it gets narrower and narrower. It gets narrowest at the core when you're really using all the jargon and all the description of your details of the work. But then it has to broaden up again in the conclusion section when you are answering the last question, so what? So try to see if your paper has that structure. Does it start and end simple? I think it's a great structure that good papers have. It's typically a structure that you see in high profile magazine. The editors there try to force that structure onto the paper. This is my really last slide. It comes from a famous writer. He's a fellow Italian. He was one of the biggest writer in history, I would say. He was going to give a series of lectures at Harvard. It's a prestigious series of lecture that many Nobel Prize winners like Toni Morrison or musicians like Herbie Hancock have given every 2 years. So they chose him, and he was going to talk about 6 values that the writer should have for the next millennium to write well. And the value that he identified, he was talking about fiction, but I think we can interpret them in terms of science writing, and I think we can relate to those very well. The first is lightness. We don't have to write in a stuffy academic way for our supervisors. The simpler, the better, always. Quickness, the shorter, the better. It's Occam's razor. Anything that can be eliminated from your papers has to be eliminated. It will just make the message more powerful. The third is exactitude. The logical construction of your paper, the logical flow has to be flawless. Your paper is an algorithm that convinces the reader of your conclusions. So design that outline of your paper, make it absolutely perfect, revise it along the writing process. The fourth, visibility. Images are powerful. Use figures very well and revise them before you submit the paper. The fifth is multiplicity, that hourglass concept. Try to design your article so that it's not just a one-fit-all solution. You can address the non-expert in most of the paper, and you can also leave something that speaks only to the expert. And by doing it properly, you allow multiple access levels to your papers. The final value was consistency. Unfortunately, Calvino died on his way to the lectures. He did not draft that memo, but I can only interpret what he might have written. So to make consistency is this, as a call, my urge to consider yourself as a professional writer. If you are a scientist, you have to consider yourself a professional writer. And if you are consistent, if you keep focusing on the quality of your writing every time you do it, every time you write a briefing, an email, a paper, a draft, a proposal, you focus on it a little bit, you try to improve, you do that consistently, very slowly, but also inevitably, you'll become much better. You will recognize that your writing has the clarity that comes from your thinking. You will recognize that your writing is about the things that really move you. It's about the passion that you have for the science that you're doing. In other words, if you are consistent and think about writing, you will find your own voice in your writing, and it will be a very powerful feeling that will be great value to your own research and to the appreciation of your research by the others. With this, I conclude, and I leave this here, but you'll get the slides. So this is in an appendix from a Review of Modern Physics article, where you can find a lot of the details that I was talking about, very specific things on adverbs and how to make sentences shorter, on what to eliminate in a paper. So I really recommend it. It's freely available. And this is I think it's an amazing book that every physicist should read. The subtitle is compelling: How to Write Papers That Get Cited and Proposals That Get Funding. And it's very short. You can get it for $30, and it's very well written. And with this, I finish. Thank you for your attention, and thank you for being here so numerous for this. And happy to take any questions in the Q&A session.
Yeah. So thank you, Matteo, for such a nice talk. I will, before we start with the second seminar, I just want to remind all the attendees that if they have any question during the talk, they can always post them in a Q&A section on the ribbon at the bottom, because we have panelists, which we have a panel comprised of editors and associate editors and managing editors of different APS journals, and they will definitely try to answer online during the talk. And of course, at the end of the second seminar, we will have a question answer session where you can raise your hands and we will allow you to ask your question directly. Okay, so let's move on to the second seminar, which will be given by Dr. Samindranath Mitra. He's the editor of Physical Review Letters. And over to you, Dr. Mitra.
Thank you, everyone. Can you hear me? Just
yeah, we can hear you.
Okay, I'm just gonna share the slides and then take it from there. Good, full screen?
Yeah.
So thank you all very much. As it turns out, some of you know that very coincidentally, I live in New York, like many of my colleagues on the screen, but I happen to be in Delhi at this time, in a very strange time for various reasons. One of them is apparently Delhi has had the most rainfall since 1964 during the last few days. So that's has changed many things around town. So let me go a little bit. So I'm kind of like a bridge between the two talks. So I'll try to change things live as I do it, because some of the points have been were initially made by Michael, and Matteo talked about some of these from the perspective of how someone should write. and also from the perspective of how a reader would look at things. So as you can see from my title, what I'm, when you're publishing physics in the pages of these journals, and for that matter, any other journals in science, it's an interaction between authors. Those are people who are doing the research and submitting the papers, referees, people who reviewed the submitted papers, editors, who are most of us on the screen here, who are overseeing the process, and then readers, of course, if the paper is eventually published, there are readers. And then in quotes, I put others. So others would be people who are people you're also trying to reach. So which could be, for example, a journalist or someone who funds your research, or the dean of the university you're at who is deciding on whether you should be promoted or not. So that's the whole set. I mean, they're also readers, but they have a different mindset depending on their role when they read your paper. So let me go through some slides, and I'll try to keep it shorter than I initially intended, because of course, most of my colleagues here will be able to answer the questions just as well as I would be able to tell them. And I think it'd be better if we get to the Q&A so you can hear more. Some of these points have already been made in the context of India. And I'd just like to point out that these are journals of the American Physical Society, but most of our interaction with the authors and referees and library subscriptions, for example, are by a very large fraction originate from outside the US. So for example, our referees are, I believe at this point, may even be 80% of our referees come from outside the US. Michael already, I think, provided these numbers that in the year 2020, which was again different from the year 2018, which was different from the year 2015, there were 17 physical review journals which published over 22,000 papers last. Just to backtrack a little bit, as a physicist, your aim is you do the research and then somehow you're trying to convey the importance of your work to the set of people that I mentioned earlier, mostly to other readers and people who have different roles when they're readers. But the tools of the trade are very few for most scientists, particularly physicists. And really, there are three tools of the trade. There are talks, there are posters, and there are papers. So, and then as you can see from this slide, at the early stages, often at the beginning of your careers, you're talking to an audience that is small. Most people in that audience are likely specialists in your field. I mean, at the very, very beginning, you're talking mostly to people in your own group. And so at that stage, you're usually giving short, what are called contributed talks, and you're presenting posters at conferences. Now, most people who are listening to those talks and are seeing those posters are typically people who work in the same field that you do, and they already know the language that you speak. So, and that's the initial stages of your career, but fairly soon you're writing papers that are for specialized journals, which have more of a paper. Even a specialized journal paper has more of a, how should I put it, a broader reach than posters. And then you move on to giving invited longer talks, often half an hour or more, and then you move on to writing papers for broad journals. Now, it turns out that I happen to work for such a broad journal, and some of us here do and do not, and then they might provide different perspectives. And then, of course, at that time, the number of people that comprise your audience is getting bigger and bigger, and eventually, as all of us that, people who do science, it is somehow in their interest to reach out to the broad public, because at the end of the day, the funding of science comes from the interest of the public. I mean, there's a very strong correlation. And so it is the responsibility, I would say, of each scientist to keep the public in general interested in what you do. And so that's the outreach, which is also the medium there, largely is talks and articles and so on. So those are the tools of the trade. Just to give you an idea of the kind of papers that we published in the pages of PRL. Now, PRL, of course, is the broad journal that aims to publish research that is also published in pretty much all of our other journals. And you might see from here that the most of the papers, and this is true of the physical review journals at large, is that most of the papers that we receive are what are called condensed matter fields. So these are condensed matter in terms of everything ranging from spectroscopy, microscopy, transport, material science, which also would largely fall in that category, and then soft matter, which is leaning towards biological physics and so on. And then we have other areas of physics where, such as, give you an example, high energy physics, particles and fields, where it is slightly, you could have papers with very large numbers of authors, so 3,000 to 4,000 authors. So we have many, many practitioners, but fewer papers. So that's high energy experimental. It's different in theory. So the point I'm trying to make here is that we get papers from a very broad range of physicists, and the numbers of papers that we publish differ from field to field. And the other challenge that we have in the journals of, in a broad interest journals such as PRL, but for many journals, including, for example, panelists will talk about this, that the concept of what is physics in quotes is imprecise and it changes over time. To give you an example here, if many of you are familiar with the material graphene, which was kind of fabricated in the sense that we understand it today in the early part of this century. And at that time, it was clearly in the world of physics. The Nobel Prize for graphene was given out soon after, within a few years, and it went to two people who consider themselves physicists. And if you had gone to a graphene conference back then, most people in those conferences came from a background in physics. But very soon, within a matter of a decade or less, in 2017, here is the mission statement, if you will, of that conference. And you can see words such as optoelectronics, biotechnology, composite materials, energy. And so the concept of graphene as being something which physicists do very quickly became dated. And this way, one could argue that it moved into the realm of materials science, the materials physics, but then it, who's to say what? I would not be surprised if more people working in the field of graphene today come from a chemistry-leaning background than from a physics-leaning background. So again, the point here is that something that is topical today or topical yesterday from the point of view of physics may not be topical tomorrow. And that's it could be that the numbers of people and practitioners grow. How many of them are in physics or not differs over time. So, and these are challenges that the journals have to face in deciding what to publish. This is a slide which is very broad. I will just flash it up here, and I think I'll skip this because these are broader issues which kind of go to the broad landscape of science publication, not specifically related to our journals, even though each of our journals has to think and address these challenges, but let me skip this for now. So the question is, why do we have physics journals? It's an interesting thing because it's not, if you think about, I've written in the first line that journals validate, that is, they tell readers that the research has been vetted by somebody as being likely correct. They curate, they make a collection of, if you look at the archive and other places, a very large number of papers are produced, so to speak. And the journals tell you, okay, from that, this subset is somehow more reader-friendly than some other subset. But the third one is interesting, disseminate. Now, used to be, when I was a student in India, many years ago now, you could pretty much only get to see research if it was published in a journal. There was no internet, there was no email. Somebody could have, mailed you by regular postal mail their paper, but that was very unlikely. So you only became aware of the existence of research if you looked at it in the pages of a journal. Now that has completely changed. In fact, I would argue that in many fields in PRL, every paper that arrives has existed on the archive, not for days, but sometimes weeks before it comes in. So the aim, the dissemination part has changed completely. Highlighting is another, and Matteo talked about this before, is that often well-regarded papers that are published in PhysRev or some other journals get very good press, are covered in the pages of top newspapers. But it's almost never the case that the newspaper science journalist is discovering such work on their own. They come across it because the journals somehow, make it available to them through their channels, which if you are interested, Matteo can talk about that more. Now the journals, so whether it's unfortunate or fortunate, that's a different question. But in this day and age, where you publish, how much you publish, what sort of citations you garner after publication have quite an impact on your jobs and promotions. And of course, the outreach part I mentioned earlier, so that also ties into the highlight part of it. Jumping forward a little bit, so like most of us, this applies to most of us on the panel here, what sort of decisions do journal editors make? So the first is physics. Of course, like I said, what is physics? Does it fall within the scope of the journals? Does the subject matter match the journal and so on? So this is a different question from whether the paper is scientifically correct or not correct. This is whether the paper, assuming it is correct, fits the journal. And then, of course, if they decide to review the paper, then they have to move on from the paper itself to look at the broader world of physicists who can act as referees for this paper. So they have to decide who is an expert on the field paper. So that's a part of the job of the editor. Then, of course, they have to look at the papers themselves with a mindset that Matteo, for example, underlined quite well as to how it is written. Does it make sense? I have seen some questions in the Q&A panel or column, which people have been asking about inclusion of details of calculations and or is that appropriate or not? All those kind of issues are directly tied to the paper as written. And then, of course, the job of the editors, the decisions are based on what referees tell them. Should the paper be published? Why? Why not? Does it have errors? Why should it appear, in my case, in my journal, in PRL, and not in some other journal? Questions such as those. Now, for a broad interest journal such as PRL, and this applies to most journals, but perhaps not all journals, the point I'd like to make is that PRL is a large journal and it mostly receives very good papers that are not incorrect. And so most papers are rejected by PRL, not because the editors somehow determined that there is something wrong with them in terms of the science, but because they felt that there was not a clear case for publishing that paper specifically in PRL. So in that sense, I call this decision subjective, because once you've determined that the paper is likely not incorrect, then the other decisions have an element of subjectivity around them. I'll skip that. I had some points which about making, as an author, you're making your case for the editor, but Matteo covered them in great detail. So even as I was talking, I took out a few slides and I added this sentence here. So Matteo, you stole my thunder here. This is, of course, one of my favorite pieces of text. And here's a picture of it. It's available widely here and often for free because people get rid of their old copies. And the three most important words in that book are these three. And now another thing I was recalling as Matteo was talking to us is that when I went to school here in Delhi and Calcutta, we used to have classes in précis writing. I can't see your faces, and so I don't know if these classes are still offered. In hindsight, I have found them extremely useful. So if those of you who have taken those classes, you know very well what I mean, that you get a page or two of text and you've been told to rewrite it in 5 sentences, 50 words, 100 words, something like that. Most useful, has really helped me in all sorts of things later on. So if you haven't taken these courses, or if you didn't take them seriously, please revisit them. Another way of when you submit a paper to us, presumably you have convinced yourself and perhaps even your supervisor that this paper, the science is good and the paper is suitable for the journal. But if you're submitting your paper to a journal such as PRL, which is of broad, you're not just talking to specialists, then one very quick way to do what we call a reality check is to ask a colleague who is a physicist, so you don't have to explain the very basics, but someone who is completely unfamiliar with developments in your field, and ask this person to read the paper, at least the introduction and the conclusion, and give you some feedback. If this person, this colleague of yours, does not understand it, then you should rework your paper. Another point, I think Matteo already made this, is that when people are looking at your published papers, they are always trying to figure out how they can go through it quickly. And so they will often look at the abstract and the title and introduction and these kind of pieces of the paper and try to avoid reading the full text. And so I think some of these are more important than others. To give you an example, when you write a paper and you post it on the archive, for example, and somebody lands on the archive page early in the morning, all they see there are the titles and the names of the authors. Of course, they can see more behind the PDF link, but they're not likely to click on that link unless something in the title grabs them, or if they are somehow familiar with the work itself or the names of the authors. So there's one. So the title is something you must work on it more carefully than perhaps you'd like to, just because it often floats out into the world without the context of the paper behind it. I'm reaching the end of my presentation. And so one of the things I'd, again, like to impress upon you, that as the author of the paper, and you've written the paper, you have convinced yourself that it's important, good work, and that you have submitted it to a particular journal, which presumably means that you want that particular journal to publish your paper. And so it is in your interest to make things as easy as you can for participants in the process, which before publication are editors and referees, and post-publication are readers. So whatever you can do to make things easy for them is worth your while. Here is, of course, a slide that I have to show is that, we talked about the wonderful history of the physical review journals. And I happen to work for PRL, which has had a very good track record, particularly lately. In fact, the last 10 consecutive years, the Nobel Prize in Physics they have cited PRLs for the original research in the Nobel Committee write-ups. Thank you. I will now unshare my slide and join you as a Q&A participant.
Thank you, Dr. Mitra. Thank you for that wonderful talk. And I now request all the attendees, if they have any questions and if they would like to ask in person, just raise your hand. And we have a panel of experts. Apart from the two speakers, Professor Rini and Dr. Mitra, we also have Dr. Abhishek Agarwal, who is Associate Editor of Physical Review Letters, Professor Dr. Katsuya Casimiro, who is a co-managing editor of PRX Quantum, Jacqueline Brandt, Managing Editor of PRX Energy, Xiangyu Yin, Associate Editor of Physical Review A, and Yun Lee, Associate Editor of Physical Review X, and Dr. Sarma Kancharla, Associate Editor of PRB. So we have all these people from APS as part of our panel. So if you have any question to ask, you can put them either on the Q&A box, or you can raise your hand and I will allow you to ask it in person. So yeah, the first person, okay, so yeah. Sumanti, please ask your question.
My question is for Dr. Mitra. Sir, I submitted one manuscript in PRL last year. It was on twisted bilayer of TMDCs, and where we addressed the basic questions of flat band formation. But it got rejected, and the only reason shown was that the topic is not of a broad interest and it's a very specific field of work. So, but we know that it's twisted bilayers are, I mean, it's topical since, 2014 to till now, and we know that so many works are getting published on this twisted bilayers on so many high impact journals like Science, Nature Physics. So my question is, how does one define a topic of broad interest when one goes to PRL?
Yes, so I think I have to. Obviously, we can chat offline about the particulars, but it's very unlikely that we, or in this case, very likely I, would have said that the topic itself was not of broad interest. I mean, this is clearly a very extremely topical area. I mean, twisted bilayer or trilayer graphene TMDCs, and so it's not the topic. It's almost the reverse. I think some topics. And there are examples such as, TMDCs or topological insulators or any other fields, you can name your favorite topics. There are of such broad interest that we get a very large number of extremely good papers even. And it's often we can, and the reality is, PRL after all is, has, so many different papers across all of science. So the reality is we'll still at the end of the day be able to publish a fairly small fraction of them. And given what I said earlier, that PRL in particular gets really good papers from many areas, and in some of these broad interest topical areas, we get a very large fraction of papers. And so we publish a small fraction, and often it is the case that the papers that we do not publish the overlap between those that we do publish and don't publish may be it is not as if it's a sharp line. So that's it. I think in these cases, such as TMDCs, it's very topical. It is a broad interest, but individual papers may not fit the bill.
Yeah.
Maybe can I add also something on that question? I think just to connect to what Matteo was saying, sometimes, I don't know the particular case, right? But sometimes it can also be the way that you are conveying the message, right? Because the editor is going to read your paper and try to see, okay, what is this result? What is telling me in this big context? And if you're not able to transmit this message, it may seem that it's a very particular study, that it's not going to bring an overall big picture view for others studying this topic, right? It might seem in a way a little more incremental in that field. But it could be just the way that you're transmitting the message as well.
Okay, in between, I will also take questions from YouTube channel. So there is Chirag Rai who is asking, is it possible that college students can directly publish papers?
Sure. In principle, absolutely.
Okay. I will request attendees, if they have any question which they would like to ask directly, please raise your hand and I will allow you to talk.
There are some questions in the chat.
There is a question in the chat by Suman Datta. How important is the identity or affiliation of an author to get published in PRL?
I can take that. So as an editor, to a first approximation, I do not know the identity of the authors or the affiliations. So when a paper lands on my desk, the first thing I'm looking at the title, abstract, and the paper itself. So what matters is the paper, not who's writing it or where it's coming from.
Yeah. There is a question on the Q&A which says, which is better a title, small and dense or descriptive?
Okay, I can answer from the PRA perspective or other physical review archival journals. You have to strike a balance between a very dense title and a descriptive title. Of course, you want the title to be concise, but you don't want to use just a few words that leaves the readers asking what key results you want to convey. So you have to strike a balance between concise and condensed title and a descriptive title that provides some information into what you are doing in this research.
Yeah.
Maybe I can add something to this. I remember a lot of titles in the papers that I see very frequently use a lot of real estate, use a lot of words to describe the techniques that they've been using. And I think that's probably not the most appropriate thing for a title. So they say characterization of the efficiency of solar cell using inelastic neutral scattering spectroscopy. So when I read a title like this, I think the paper is not about the physics it contains. It's about, they want to say, oh, we just use this technique, and it's about the experiment. It's about the how. It's not about the, I expect it to be sort of a technical result that has little physics novelty in it. And sometimes it's not true. Then you read the paper, you realize it's not true. But I would say those details do not belong to the title. So try to focus the title on what is really the new element of physics that you are publishing, and not on the techniques you use. And you may love your technique, and that's, you've worked on it for so many years, but you talk about it in the abstract and things like that. But the title should give a sense of really what is the message that matters, not the way you obtained it.
Okay. There are a couple of questions which have similar flavor, so I will just combine them. One is in the chat, other is on the YouTube. The chat question is, can one submit to APS a manuscript without affiliation? And the question on the YouTube is also something similar. It says that, is it necessary to have institutional mail for sending paper or see the old papers? And what about the beginners? Can they just publish it without affiliation?
I think I don't know if I think it is rare enough that I do not recall a paper without any affiliation whatsoever. However, I don't think we have an explicit rule that you may not do so. Correct me if I'm wrong, someone else. But it's so rare that it's an instance of zero numbers.
I would add that I have at least
home addresses are fine.
I would say that
Right?
I've seen at least one paper submitted from prison.
But published, maybe none. And also, but home addresses are not uncommon, I think, right? I think uncommon maybe, but not non-existent.
Yeah. Then there is one question which is all about, which is asking what stand do you experts take on websites like Sci-Hub?
Sorry, can you repeat the question?
Yeah, the question is, what stand do you experts take on websites like Sci-Hub? Am I audible?
Yes.
Yeah.
Sci-Hub is illegal.
Okay. Any other questions that attendees would like to ask? I actually would like to ask one question then, that typically when any researcher look for relevant papers in a field, they go to, say, for example, Google Scholar Search or Google Search. to look for, articles in similar areas or whatever. How much role a title plays in actually getting a maximum exposure to your article in such kind of searches or search engines?
So is the question whether the author should pay attention to the title because it may be picked up better via search engines? Is that?
Yeah.
I think it's become clearly in 2021, not just the title, but also you can do full text so much. And so they are important. I think people have to, the way I think about it is a title is important because, as I mentioned before, on the archive listing or on tweets that people make on, which has a big role now in many instances, the titles kind of float out into the world without the context of the paper behind them. So they're often required to stand on their own. And so they have that role. I think abstracts are a different beast in that it is, to me, almost a collection of, this is why I refer to précis writing, of useful keywords that are combined in a very readable piece of text. So, for example, if you're writing a paper on twisted bilayer in dichalcogenides, so if the words twisted, bilayer, dichalcogenides, photoemission, or whatever you want to convey do not appear through a search term, then you might be missing out on some intended readership. So I think all of these are very important, but at the same time, it cannot be a bunch of keywords thrown at a wall and they stick. You have to then combine them for the abstract and introduction. So I think that, because of the search engine optimization concept, these have become more important than I would say even 15 years ago.
Yeah. There is one more question on the YouTube. I'll just read the question. Sometimes the reviewer report points the purpose of the study incorrectly, even though the manuscript talks about the motivation explicitly. How to take these kind of rejections? So basically, the reviewer points out something which is actually contradictory to what exactly is spoken or said in the manuscript. So, and hence the reviewer actually rejects it, but the author feels it is not consistent with the writer. How to take such kind of rejection?
I can take a stab at that. So I think it's very important to, first of all, regard the reviewer as part of your team, right? Part of that annoying skeptic in your, as the annoying skeptic in your team, not as your enemy. So the message that I would try to take away from that is that if the message is not clear to the reviewer, then perhaps the message was not expressed clearly enough. And if it is not clear to the reviewer, it's likely to be lost to other readers, because other readers are likely to be less committed to reading the paper than a reviewer who's been charged to review the paper, right? So I can understand the frustration that one might feel if one submits a paper and sees comments from a reviewer which raise questions which you feel have already been answered. But the message to take from that is, first of all, receive them in good faith, and ask yourself, well, did I really make it clearly enough? Maybe it wasn't made clearly enough, and give it another shot, because typically, you do get a second round of review. And if that doesn't work, then that's a different story. But as a first approximation, I would say that take a feedback like that in good faith and question if you have made the point clearly enough in the paper.
Okay, there is one question in the chat box which is, how long should be the conclusion if the main part is around 10 pages?
You can take that one, but I don't think it's really a matter of counting the pages, but it's more like that you can present in the conclusions a clear message, what have we learned with the paper, and then tell what that means, where this research could be extended now that we have these new results, what are going to be the next steps that we could envision for the research following up from this work. So we want to know what are the new paths that are open by this result. So that's the message that you have to give in the conclusion. And it could be, I don't know, 2 paragraphs. As long as you can explain well that part, that's what matters.
Yeah, there's another question which is, how long time will it take to publish a research paper in journal? Is there any standard time limit?
Okay, so it varies a lot depending on the journal and also I think the specific field. For some areas, the reviewers are kind of, I don't know, there is a culture of doing a fast review and then everything goes smoother. In other areas, the reviews, they immediately say, oh, I'm gonna take 60 days to review that. And it's a culture of the community, so it's a little hard to control all of that. But from the point of view, from the editors, we do our best, right? We try to be always promptly looking the papers and so on, but then it's also case by case. In some cases, the editors can easily look at the reports and come up with a conclusion. Some other cases, you might need a few days to really study and see what's going on. So there is a huge fluctuation on that. But maybe if I add typically with a large uncertainty on that, let's say that in about 1 month, you should have the first reports, but that there is a huge fluctuation in this number.
Yeah, and the time scale can also depend on how many rounds of review the paper needs to undergo and the amount of time that it takes between the time that you accept the peer review, that you receive the peer review reports until you do revisions and send it back. So yeah, there's a pretty big fluctuation.
Yeah, there is another question on the YouTube, which is, how does a page limit decide the paper is perfect or not? I mean, how does one decide how many pages one should have to have a perfect paper?
Well, I think for some, go ahead, Abhishek, go ahead.
No, I was just going to say that it kind of depends on who your target audience is, right? I mean, if you really want to make sure that the involved experts in your field really understand every detail and follow up on that paper, if that's your target audience, then of course you would want to write a long paper with as many details as you think are likely to be of interest to people. On the other hand, why do people write letters? I mean, you're writing a letter, for example, not just to convey an important result, but also to make a statement that, hey, I've done something, that's a big deal. It's a big deal either because it's a really important result in the subfield, or it's a big deal because I'm bringing ideas together from different fields. So if your statement is to, basically say that, hey, I have something that everyone should pay attention to, and for that reason, you've chosen to write a letter type paper, then yeah, you need to focus on what that big deal is and write a shorter letter type article where the emphasis is on what is new, what's important, why should people care about it? And then you can write along with it at the same time or later, a longer paper directed towards the experts where the details are fleshed out. So it really depends on who you intend to talk to. That kind of guides the length of the paper that you are writing.
Yeah, I think I would like to add on that as well, and maybe take the chance to talk about our journal, because I have seen some cases that it's just, it's rare, but there are cases that you have this very important result, but you cannot fit in a letter size. And then some authors try to do it by using a lot of supplemental material, and important results of the paper are in the supplemental material, and then the editors are going to say, and the referees as well are going to say, look, this is not working. You have too many important things in there. It's not a letter paper. So then there are other options that we are offering APS that you can publish a longer papers that have a very important results. And then you have PRX, that there is no length limit. And then you have now what Mike was explaining. We have other series of PRX journals, PRX Quantum, where I work, which is focused on the quantum information science and technology community. And you have also coming up PRX Energy. So there are other options that you can explore. But then I would say the length limit, I mean, it's what Matteo was saying, you have to tell a good story. And so try your best story, and then you see what's the length that you get. If you don't fit in a letter, don't try to make it shorter than you can, because you're gonna not succeed in the review.
Absolutely, fully agree.
Maybe I can add one thing. Basically, you want it, if you're targeting to a journal that is catering to experts in the field, then it should be at least the length that would permit the paper to be reproduced, the research to be reproduced. So that should be a good guideline to say that, you know, an expert in the field can understand it fully and see what were the conditions under which the research was done. So, yeah.
Yeah, another question in the chat box is how to select the relevant reference papers for a good quality and how important these references are for the paper.
I want to add something to this very good question, because the literature search is a very important part of your research. You want to be aware of what are the research that has been done in this field that you're working on. One of the tricks I can think of is to find a good review article that's probably published in Review of Modern Physics or other review journals. You can look at those review articles and see what work has already been done and what is going on in this field, and do your research on those papers that cited in those review articles. Also, you also want to do your own research on what has been done recently, because review articles sometimes they have a time lag between the review article and your own research. So do a good job on literature search and cite all the relevant work. That is very important.
Can I add a little thing? I don't know if you have we have another question or?
Yeah, we have one more question.
Then it's okay. Let's move on.
Yeah, we can. So the question is it good to raise our concerns to the editor over a rejection if one felt unfair about it, or just simply proceed to another journal and since the chances are less to get second hearing? So how to decide about whether to put a rebuttal if an editor has rejected a paper based on the referee report? So what is a good strategy?
Yeah. So maybe I can try to answer this question. So if the paper has been reviewed and rejected, and you feel a referee might have overlooked something, it's always not too late to raise that to editors. Just write a message clearly and constructively. Explain why you think referee have overlooked something, and then very likely the editor may reconsider or contact the referee to confirm that. If the paper has been rejected without review, you can also write to the editor to ask for reconsideration, and please explain the reason why you think there might be something overlooked, or why you think the result is very important that maybe the editor didn't be aware and wasn't aware of that. So there's always a way to communicate with the editors and the referees.
Okay. Are there any questions? Any other comments that attendees would like to make? They can raise their hand as well.
I see someone is complaining they cannot download their slides. I will have to grant you permission. So probably I will have received your message, and as soon as I'm offline, I will give you permission. So that should be possible.
Okay. Okay, is there any more?
I see there are 3 questions in the Q&A. Did you take those? Did you see those?
No, I haven't. So I will just go there. Yeah. So the one question is, how risky is it to make broad claims, scientific or philosophical, about the implications of your results in the conclusion of the paper?
I think from the tone of this question, it seems when you say broad, it means that you don't quite know if they're going to be tied to the paper. And if you are thinking that at all, then you should not make the claim. I mean, this is like, when you're driving and you're trying to make a turn onto a busy street, if you have to think about it, the answer is always don't make that turn. So it's the same here. It's and certainly if the claim is very likely going to be recognized by experts in the field as questionable, if there's any possibility of that, there is just no reason to make that.
Yeah. The second is to search the relevant topic with relevant word or another any keyword, which I get my desired results quickly. I think this is in context with some other point which was made earlier, I suppose. And then there is a question of I'm a 12. I'm in grade 12 in India, and I think I have disproved uncertainty principle in my research, so something like that. So I think it was answered by one of the panelists. So I will not take that question. Okay.
Well, I would tell that person. Well, first of all, if he did, congratulations. Very likely he has to, confirm me and do some more work. So I would say he should continue to study physics, go on and make sure that his reasoning works. And if he convinces himself that he has done it, that's a big deal. It's obviously very unlikely. We get a lot of these claims from people who do not have a full scientific background. So I would say, go on, become a physicist, and then check your claims again and see if it stands. But the claim you're making is so strong. It's like when people said, "Oh, we measure neutrinos and they move faster than light." And somebody said, when you see something like this, you don't go and make an announcement. You go back and see where the mistake was. So it's something similar here. If you claim you prove the uncertainty principle, probably there is something wrong in the theory that you are deriving. So go back and check everything, study more physics. Maybe some point, maybe you'll find that you are right, but you will need a lot of arguments for such an extraordinary claim.
So this question from Arca is not clear to me. I don't know if it's clear to someone else.
No, I think it was. It must be the comment to some other previous question or something like that during.
Oh, okay. All right. Okay. Mm-hmm.
Yeah, but there is one question on YouTube where somebody is asking that, at least for the beginners, how one can download old papers from archive. Are these papers accessible?
By old, if you mean before, I mean, the archive came, I don't know, I mean, the archive goes back only a certain number of years, and before that there was no archive. Sorry, Abhishek?
1992, yeah.
1992. So if you're thinking of seminal papers that, for example, help you understand uncertainty principle, then those papers are not on the archive. But anything in the archive is more, I think the great part of the archive is to give you a very broad overview of what is happening today and in the very recent past, so that if you're already a practicing or about to be a practicing physicist and you want to get a good sense of what people are doing right now at this time, the archive is in physics for sure.
Yeah. Then there is one question. I think maybe this can be the last question of this session, which is, what impacts more when it comes to pass through the initial editorial screening in PRL? For example, given two examples, a reasonable scientific conclusion conveyed in quality English, or quality scientific conclusion that lacked the power of English. Which one the editors prefer to pass through to the review process?
Again, I'll try to answer that. As Matteo said, English is really a secondary concern. What matters is the result. There isn't a magic recipe based on formatting or pictures or images or style that'll make the paper pass the initial screening. PRL is a highly selective journal, and what we are looking for is there a good reason based on the result for this to be spotlighted in some ways? A publication in PRL means you're spotlighting a paper, telling the world over, telling the research community as well as funding agencies or your department that, hey, this is really special. So is there a statement? Is this the first calculation of something? Is it the first measurement of something? Is it the most precise calculation of something? Is it the first time something like X has been done? Is it the first time that X and Y have been combined together? What is the big deal, scientifically speaking? English matters. Of course, if you make a paper easier to read, it's easier on the eyes, and it makes my job somewhat easier. But my job is not to reject the paper just because I found it difficult to parse. My job is to figure out whether there's a good reason to review this paper based on the promises it makes. So what matters is the scientific content. Of course, writing matters, and the better the writing, the easier my job becomes, and sometimes the entire process can become easier. But fundamentally, what matters is the science.
And I have to say, I've seen decisions by the editors where you're telling the author, okay, send it to an editing service or get it corrected by a native speaker. So you can get, I mean, if you think that the paper has good scientific quality to publish, but not enough grammar to look professional, you just tell them to do that. But it's not an obstacle for publishing. So.
Yeah, and maybe the last question, because this will have just one word answer, or maybe one single short answer. Which journal of APS are the best to look at when one is very new to a topic and to get a good overview of it?
Easy answer. Reviews of Modern Physics.
That's right. I was going to say.
I was about to write that, but then I thought maybe the APS guys should tell rather than write. Yeah.
So maybe I can also add Physics Magazine, because
I was going to say Physics also. Yeah, because I think reviews of Modern Physics can be a little. I mean, it's the biggest overview, but it's a little daunting because it has a lot of depth. Whereas Physics, you can get a general sense of many different, topical.
Yeah, I would say it's a good place if you're curious and you want to, read a paper about gravitational waves, read a paper about neutrinos, read a paper about topological insulators, and get a gist of where it goes, and sometimes a tutorial explanation. I think, for a person like this, probably they would benefit a lot, and then maybe they can focus on what they really want to do and go to review Modern Physics and to the other journals too.
Yeah. On Q&A, somebody is asking how to become member of APS. So if
Vaibhav, can I just quickly ask a question?
Yeah, please.
I think, is it possible, because we may not be able to take some more questions, is it possible that some of the participants can send these questions by email or something? If so, we can put out that address.
Yes, feel free to give my address to anyone that wants to. So which I listed, I'll write it here again just for everyone.
Yes, if you can put it in the chat box, that will be great. Yeah, thanks.
Yeah.
Thanks.
Yeah. So
however, I'm on vacation in India, so my answers may be significantly delayed.
So I'm also going to put that out on the YouTube chat.
Yeah. So with this, I would like to close this session. But before that, I would like to thank all the panelists and particularly to speakers for such a nice and wonderful talks, seminars, and full of information. And I'm sure all the students and postdocs who have attended these sessions have benefited or will definitely benefit in future, and will take home good messages to improve their papers and make it more possible to get it published through APS. So I once again thank all of you, all the APS team which worked to get this, make this happen, and also at the IPA, all the IPA team which has worked hard to make this happen. So with that, I declare this closed.
So just one word before that, Vaibhav, thank you for conducting this session and arranging it on a short notice. And thanks a lot to Professor Pentavadia and Dr. Amy Fletton to get all of this initiated. It was their initiative on getting this IPA APS together has resulted in many things, and we look forward to more such programs. So thanks to all of you. It was nice to see Michael again also after some time, and we hope to see all of you again soon. Yes, thank you, Vaibhav, and thanks. Over to you.
Thank you, Vandana, and thank you all the panelists.
Thank you.
Thank you for organizing.
Thank you. Thank you.
Yes,
Thank you.
Thank you very much for
Thank
putting
you.
together and hosting this.
Yeah.
Hopefully we'll be in person next time.
Yes.
We look forward
We
to
would
that.
be happy to welcome you to TIAFON.
Yes.
Okay. So I will now close the webinar, and I will.
Yeah.